Hello students, this is Dilip Udhani, Assistant Professor at LJ Institute of Engineering and Technology. Today I will teach you one topic of Laplace transform that is called convolution theorem. With the help of convolution theorem, we can find out the inverse of a function if two functions of s are multiplied together, right? So what is the statement of convolution theorem? If you have been given two functions, one is function of s and other is function of again s, say one is f of s and other is g of s. And if you have to find out inverse Laplace of that particular function, that is f of s into g of s, so that is given by this integration. This is called convolution theorem. So what is the statement? If L inverse f of s equals to f of t and L inverse g of s equals to g of t, then convolution of f and g, right? This is denoted by the symbol f star g. This is called convolution of two signals, okay? One is f and other is g, and that is equals to L inverse f of s into g of s, and that is equals to integration from 0 to t f of u g of t minus u du. So with the help of this theorem we can find out the inverse Laplace of f of s into g of s, okay? So for this purpose you have to remember some formulas, right? So that is L inverse of 1 over s, that is 1, L inverse of 1 over s minus a, that is equals to e raised to at. L inverse of 1 over s plus a, that is e raised to minus at. L inverse or inverse Laplace of 1 over s square plus a square, that is equals to sine at by a. Inverse Laplace transform of s upon s square plus a square, that is cos at. Inverse Laplace transform of 1 over s square minus a square, answer is hyperbolic sine at by a. Inverse Laplace of s over s square minus a square, that is hyperbolic cos at. And inverse Laplace transform of 1 over s raised to n, that is t raised to n minus 1 over n minus 1 factorial, right? These formulas are very useful to find out the inverse Laplace of f of s into g of s, okay? Now this formula is also very useful, that is first shifting theorem. If inverse Laplace of f of s is f of t, then inverse Laplace of function of s minus a, that will be e raised to at f of t, okay? This is called first shifting theorem. If you have to find out inverse Laplace of function of s plus a, then it will become e raised to minus at f of t in this way, okay? Now I will make you understand the convolution theorem with the help of one example. That is, we have to find out inverse Laplace transform of s plus 2 over s square plus 4s plus 5 the whole square. From this function, right, this whole function, we will assume f of s and g of s. So let f of s is s plus 2 over s square plus 4s plus 5, and g of s is 1 over s square plus 4s plus 5. Now according to convolution theorem, first of all we have to find out inverse Laplace of f of s and inverse Laplace of g of s. Inverse Laplace of f of s will give us f of t, and from that we will find f of u, and inverse Laplace of g of s will give us g of t, and that will, from that we will find out g of t minus u. Then after, with the help of this formula, we will be in a position to find out inverse Laplace of f of s into g of s. Okay, so now we will find out inverse Laplace of this function, that is s plus 2 over s square plus 4s plus 5. We will find out inverse Laplace transform of this function with the help of first shifting theorem. Okay, in the numerator we have function of s plus 2, and in the denominator we have s square plus 4s plus 5. So we will split this 5 as 4 plus 1. By doing so, this one will become perfect square of s plus 2. So in the numerator we have s plus 2, and in the denominator we have s plus 2 the whole square plus 1. Now we will find out inverse Laplace of this function with the help of first shifting theorem. We will replace s plus 2 by s, right? So it will become s over s square plus 1 square, right? Now if we are replacing s plus 2 by s, so we have to write down e raised to minus 2t, right? So e raised to minus 2t, L inverse of s over s square plus 1 square, and L inverse of s over s square plus a square. Answer is cos 80, right? So here L inverse of 1 over s square plus 1 square, it will become cos 1t, and L inverse of f of s, that is f of t. So we have f of t equals to e raised to minus 2t cos t. But we have to find out f of u. So what we will do here, we will replace t by u. So we have f of u equals to e raised to minus 2u cosine of u, right? Now similarly we will find out inverse Laplace of g of s. G of s is 1 over s square plus 4s plus 5. Now splitting 5 into 4 plus 1. So s square plus 4s plus 4, it will become perfect square of s plus 2. So this will become 1 over s plus 2 the whole square plus 1 square. Now we will find out inverse Laplace transform of this function using FST, that is called first shifting theorem. L inverse of g of s, that is g of t, we will replace s of s plus 2 by s. So we have to write down e raised to minus 2t multiplied by L inverse of 1 over s square plus 1 square, and L inverse of 1 over s square plus a square. Answer is sin 80 by a. And in our case we have L inverse of 1 over s square plus 1 square. So the value of a is 1. So it will become e raised to minus 2t sin 1t. Now we have to find out g of t minus u. So what we will do in this expression, we will replace t by t minus u. So it will become g of t minus u, that is equals to e raised to minus 2, replacing t by t minus u into sine of t minus u. Now we will use the formula of convolution theorem, that is L inverse of f of s into g of s, that is equals to integration from 0 to t f of u g of t minus u du. Okay, so now L inverse of f of s is s plus 2 over s square plus 4s plus 5, and g of s is 1 over s square plus 4s plus 5. So it will become L inverse of s plus 2 over s square plus 4s plus 5 the whole square, and that is equals to integration from 0 to t f of u g of t minus u du. Okay, now integration from 0 to t will be as it is f of u. F of u is e raised to minus 2u, right, cos u. Okay, f of u is e raised to minus 2u cos u, and g of t minus u, that is e raised to minus 2t minus minus plus 2u. So e raised to plus 2u and e raised to minus 2u. So minus 2u plus 2u will cancel out, and the after simplification we will be having e raised to minus 2t, okay, and multiplied by sine of t minus u. Now we have multiplied this result by 2 and divide by 2, right? Okay, so this is, now we have to integrate this function with respect to u. So before integration, we have to apply the formula of 2 cos alpha sine beta. Okay, the formula of 2 cos alpha sine beta, that is sine alpha plus beta minus sine alpha minus beta. Alpha is u and beta is t minus u. So sine of u plus t minus u. So u will cancel out. We have sine t. And after minus sine of alpha minus beta. So u minus of t minus u. Okay. So minus minus plus 1u plus 1u. It will become 2u and minus t. Now we have to integrate this function with respect to u. Remember here the function of t is constant. So e raised to minus 2t by 2 will be as it is. This sine t is constant. Now integration of 1 with respect to u, answer is u, and its limit is from 0 to t. Then after this minus sign, and integration of sine is minus cos, and multiplier of u is 2. It means you have to divide it by 2, and the limit is from 0 to t. Now for upper limit it will become t sine t, and for lower limit it will become 0. So the result is t sine t. Then after for upper limit it will become 2t minus t. So it will become cos t by 2. So minus minus plus, so we have cos t by 2. And then after minus sign, replacing u by 0, so it will become cosine of minus t, and cos is an even function, so we can write down this one as cosine of t divided by 2. Okay, so plus cos t by 2 and minus cos t by 2 will cancel out, and the result is e raised to minus 2t by 2 multiplied by t sin t. So this is the inverse Laplace transform of required function, that is this one. Okay, we will see more examples related to this topic in next lecture. Thank you for watching this video.